everyone. My name is Thisara Pramuditha, and I would like to welcome you all to this edition of React Native Meetup. So in our previous sessions, we had covered most of the aspects of React, like how we can efficiently use forms in React, React hooks, and how to manage state with Redux and React router, and so on. So in this edition of Meetup, we'll mainly focus on how we can improve performance in our React web applications. So just a small note before we begin, if you have any questions, there is a link provided in the comment section where you can ask all your questions, and our team will get back to you as soon as possible. So I think most of you have heard about Dan Abramov, developer at React team. So the intention of this session is to give you a brief idea about how performance can be improved in React. So I am the messenger, and I'll walk you through the implications and how we can potentially improve the performance in React based web applications. So we are mainly gonna discuss these following topics. So first, let's get a brief understanding of what and why aspects of web performance. Also, as we all know, React is performant with the use of virtual DOM, and we'll have a high-level look at how React achieves performance internally. Then we will have a look at things that we do suboptimally in our React code as developers, which affects the performance aspect. Also, before moving on to the ways that we can improve, we'll have look at how we can identify these performance bottlenecks, and finally we'll look at how we can improve performance in React web applications. So what is web performance? In simple words, we can say that it is how fast your web page loads and how quick it responds to user interactions. Also, we need to consider about the animations, and as well as how the scrolling works as well. So your animations and the web page scrolling should be smooth, since users are really sensitive to these animations and scrolling. So going forward, based on this image, so you can see the speed of the page load makes a significant contribution to web page users experience. So we in next slides we'll look at how we can why we need to think more about performance. So the $1 million question, why performance? Today when we browse, we are not that patient if it takes more than 10 seconds to load our web pages. So according to some studies, that they have found out that 50% of users will abandon sites if it takes more than 5 seconds to load. So therefore, the performance plays an important role in improving the user experience and reducing loading time. So as I have mentioned in previous slides, so performance directly impacts the user's experience. Therefore, better performance provides a better user experience. So, and also when it takes more time to load the page, then users will not look forward to revisit your website. And another aspect is loading speed also affect the search engine optimization rankings, and more users will access your content if your page is ranked higher. So what search engine optimization does is there are some factors that consider, and it will rank your web pages in Google search engine and some other engines as like Bing. So page load is important for search engine optimization, because like it is one of the key determining factor where Google algorithms are considering when ranking the websites. So slow sites turn visitors away, fast sites provide good user experience for your visitors. So if your page loads faster, then Google will rank your websites in a higher. So, and another thing is like as we are mostly doing Google search, and if we like search something and we are highly unlikely to navigate to the second search result, since we will mostly run through in the first page. So it has effect with the performance as well. So all these factors combined will affect the revenue of your business or your concept. So Amazon has found out that every 1 second delay in their website, so they will reduce the revenue by 7%. Whereas like if their per day value is 100K, then the loss will be around 2.5 million per year. On the other way around, Walmart has discovered that they have gained revenue by speeding up their websites. So these numbers are in millions, and when there are performance issues, they affect the revenue in millions. So I always repeat performance at every turn. Performance feel like a kind of a qualitative attribute, and it can be varied based on some factors as well. So next we'll see whether there are any metrics that available for performance calculations. So this is the model that I have found out, like named as Google Rail model. So which is a user-centric performance model that provides a structure for thinking about performance. So this model consider user experience in some actions like response, animation, idle, and load. So with this, the user expects performance in different aspects. So we'll see like the user perceptions of performance delays. Yeah, like if you look at these time windows with some actions that user can perform inside your applications. So 10 to 16 millisecond window, whether like your animations should work smoothly, and 0 to 100 milliseconds, the response to user interactions should be within that range, and 100 to 1000 milliseconds page loading time or page navigation should work, and now like 1000 and beyond, like it's like 1 second and beyond, users will not focus more on the task what they are performing, and 10,000 milliseconds or 10 seconds beyond, like as I have said earlier, users will likely to abandon the site. So this model provides a comprehensive guideline to track the performance of our application. So if you search on Google about Google Rail model, you can get more idea about that. So before moving on to how React handles the internal processing, let's have a high-level look at how the DOM and browser works internally. So that makes easier to understand how React achieves performance through virtual DOM. So in this diagram, there are like few steps. So first, like the browser passes the HTML to construct the DOM tree, and this is the DOM is called as like document object model. When combining DOM with CSS styles, you get this render tree. So that's the second point here. So in the next point, like the layout phase, it will calculate the positions of every node in the render tree. Like every node means like every HTML elements. So and so you can imagine that this process can be expensive because like it has loads of calculations to for every node in the tree. So at the end of this layout of the render tree stage, the browser knows each element's exact positions and the sizes. So in the final stage, where the browser will paint the elements in the viewport, where like it has to go through each and every pixel of your viewport, where you have to do a lot of computation heavy steps in there. So like people tend to say DOM is slow, but actually the DOM itself is not slow, but the all of these processes are what makes the DOM updating process slow. So we know DOM is a tree structure, and traversing in tree is fast and efficient. But as I have said earlier, the laying out the render tree and the painting the render tree are some computational intensive work, and which makes a bit slow when it comes to updating the DOM. So I'll like take this example to explain how React achieve performance with updating the DOM. Like here I have a DOM structure with like some HTML elements, and so this on the right side you can identify these elements in a tree structure. So these elements are shown in the web browser, and so React first it will create this virtual DOM. Like simply we can say virtual DOM as a lightweight copy of the actual DOM. So Next, so here I'm gonna change one element of this structure, like which I have colored in red. So this at here, please note that I have not changed the UI, but starting to update this exact element. So then the next step is like the first, when I am updating the React virtual DOM, will change this exact element, and it will like compute the difference between the previous version of virtual DOM and the current version of virtual DOM. So this is the thing where like the diffing algorithms comes in, where like it will compare the current and the previous state. So here the conclusion will be only React will identify this redly noted element has been updated. So then what virtual DOM will do is only update this exact UI element rather than laying out the whole tree. So therefore only updating a part makes it faster rather than going through the whole DOM structure. So that's how React achieves its internal performance. Like so the manipulation of DOM is slow, but manipulation of virtual DOM is fast, and so the reason is the virtual DOM is not drawn on the screen. So there is another thing that we need to note, that virtual DOM is not quicker than simply fetching one element via like get element by ID and changing it. The comparison is between two ways of dealing with changes in complex substrees and not just considering a single element. So this, for like I am just here changed a single element for your easier understanding. So now let's have a look at like some things that we are as developers doing like to affect the performance in a negative way. So the main impact with React usage is not thinking of unnecessary re-renders where the DOM gets updated unnecessarily. When it comes to the diffing algorithm, it has some considerations that makes the diffing algorithm fast by comparing the parent and parent component updated, then the children components will also get updated. So if you are like want to learn more about diffing algorithm, you can go to the React documentation, and there are lots of information available there. So like then we have to like consider about the use of context API extensively. Like also it can make application having unnecessary re-renders, and I'll explain about it more on the ways that we can improve performance. Also, not using lazy loading methods is another aspect. Like you can use React Lazy and React Suspect. So I'll talk you more about in the ways that we can improve. Also, like creating animations with only using JavaScript can be also have an impact on the performance. So moving on, like before moving on to the ways that we can improve the performance, we'll have a look at what are the tools that we can use to identify performance bottlenecks. So there are mainly two tools that we can use, the React DevTools profiler and the performance tab in Chrome DevTools. So in this session, we'll mainly focus on React DevTools profiler. So this is like a sample view of the React profiler. So there are some considerations when you are using React profiler, like if the React version should be above 16.5 and above. So also, like it is work with mainly optimized production build. Like if you are gonna use profiler in the production environment, it won't work actually. So what you can do is you can create a optimized production build enabling with profiler. So mainly profiling with use profiler with production enabled profiling build is much more effective, like rather than using it in a development environment. So if let me show you the profiler. So this is the profiler view. So you can, like, there is this Chrome extension you can download from Google. So if you add, there is profiler tab in the Chrome DevTools, and there are few graphs there. This is a flame graph chart, and also you can see this rank chart. And these are the commits, like in when React is working, there are like two phases, the render phase and the commit phase. So if I go to this diagram, so here, like, there are these two phases, the render phase and the commit phase. Like in the render, it will like updating the GUI, and in the commit phase, it mainly updates the DOM. So the commits are here, and it will show these charts are the ones, each component has the length of the component represents the time it took to render. So going back to the presentation, like, I'll show more about them. So finally, we will look at the ways that we can improve the performance. So there are, like, I'm gonna divide into some aspects using fundamental ways of React. So first, let's have a look at the demo app, and so we'll go through the each of these updating performance updating aspects. So this is the sample demo application that I have created here. So there are this input here and a chart with on the bottom. So I can like change here. You can see like it is not, so I'm here already typing, but it's not responsive since the bottom component is artificially I have added a calculation where it makes a bit slower. So if I go to the code, so this is the code where like I have a component, functional component name memoize page, and there I have this input and as well as the expensive component. So in this expensive component I have added an artificial delay there, so it makes rendering a bit slower. So also I have a state variable which is named as color. So whenever like I am changing the input value, this color variable gets updated, and because this state variable getting updated, this whole tree will re-render. So actually when it is re-rendering, this expensive component should not be get re-rendered since we are not passing any props to this component, as well as like it is should not be updated since it has some rendering slowness. So first like this, so let me show you with the profiler. If I go to the profiler and you can press this start profiling button and do your action here. So, and after the action you can stop this profiler. So you can see there are few commits. If I navigate between commits, you can see these yellow colored ones are somewhat expensive. So, and you can also see why this component has re-rendered. So according to this, the parent component re-rendered. So actually, according to this case, you should not need to be re-rendered this expensive component. So you can identify using profiler whether there are like expensive component renderings in like there are few color values, like the gray ones are the ones that have not been rendered, and the blue ones, and the most expensive ones are in the yellow color. So let me first look at this one. So move state down with a new component. So like now the thing is I will move this input variable and the text to a separate new component where like this. So now it only has the state there, and it will only pre-render this part of the page where whenever the color state variable gets updated. So first let me comment out these, and I'll add this state down component here. So comment out this. Now if you go to this web page, so if I am typing, you can see now it is updating fastly. So let me profile and again show you. So do and stop. So you can see the commits here. When I am navigating through these commits, the expensive component did not render. So that is one way we can achieve if there are unnecessary re-renderings in like these situations. So it can be vary at some according to your situation, but here I am using a simple example to explain how you can improve the performance and as well as reducing the number of unnecessary re-renders. So another thing that we can use here is lift the content up with a parent component. So this is a code example that I have, a code snippet that I have added here. So what you can do is like you can create a parent component here and pass this expensive component as children. So I've like not gonna go deep here. So if you are like to learn more about this, you can like pause Google, and there are multiple resources out there for that. So the second thing is using memoization. So in programming, memoization is an optimization technique that makes applications more efficient and hence faster. So it does this by storing the computational results in cache and retrieving that same information from the cache the next time it's needed. So when I am like using memoization with React, it will compare the updated and the previous render. So if there are no any changes, it won't get updated. So first let's move to the code, and I'll show you how we can use memo to solve the same situation that we had. So I'll remove this component and uncomment this. Okay. So now if I go to my application and do some update, you can see it is not updating effectively. So if I stop the commit, then you can see the expensive component is re-rendered again and again. So I'll go to the expensive component and use React memo to memoize this component, where like you can import this memo from React and wrap your component with memo. So if we save this and I'll do a profiling again. So you can see now the expensive component does not get pre-rendered, like, so it also stating that the component has been memoized. So that is use of memoization, and there are like two other things as well, like use callback and the use memo. So here I have added a small example where you can use how you can use callback to memoize your callback functions, and also this is also a simple code snippet that I have added to show you how you can use memo to memoize your calculations. So if you have any doubts, you can go through the React documentation, where you can find out more information about use memo and use callback. So another thing that we can use is lazy loading methods. Like in React, there is this code splitting with React lazy and suspense, where whenever React builds, it will create a chunk file, and what React lazy and suspense does is it will be divided into multiple chunks. So let's say if your website has a login page, and you are loading the login page, so it will only download the necessary chunk file, and not the whole chunk where the other pages are and the other components are available. So it will make your page load faster. And also another thing is when you are using images, they can also be lazy loaded. So these are some other factors that you can use when it comes to optimizing the performance. So lists can be like kind of heavy when it comes to have a virtualized list, and so you can use virtualized list with windowing, so it can improve the rendering of your pages as well. And also another thing that you can use is CSS animations instead of JavaScript animations, as if there are any possibilities, like moving to CSS is more performant comparing to using JavaScript. And if you are need to use JavaScript animations, like it's better to use well-known JavaScript animations libraries. So, and in a final thing, you can also use gzip compression on your web server when you are using React web application. So in a summary, we had looked at why we need to think about web performance and the what aspect as well. Then we had looked at the Google Rail model, which is a performance measuring model that we can use to as a guideline. Also, we looked at how React does its internal performance through Virtual DOM, and then we briefly discuss what are the aspects that we need to consider improve the performance, and then we look at the tools that we can use to identify performance bottlenecks. And on a final note, we look at how we can mitigate the performance issues. So I hope you got something out of this session. So If you have any questions, please feel free to go to that pinned link on the comment section. And if you have any doubts with this session or any questions related to React, please feel free to contact us as well. So yeah, so that's it for this edition of React Native Meetup. We'll catch up to you later with another episode of React Native Meetup. So thank you. Bye bye.